Hello everyone, my name is Mr. Tang. I'm here to do a video on electricity. So as you can see on the board right there, electricity is a topic that most students will learn from Sec 2. So depending on whether they are the Express, NA or the IP stream from Sec 2, they will be learning different formulas for electricity, but in general they should fall under the same category. So for this particular video, what I'm going to do is I'm going to talk about electricity, which is applicable for Sec 2, be it you are NA, Express or even Sec 3. Doesn't matter whether you are combined physics or even for O levels pure physics. Okay, so these formulas are very easy for you to learn and to execute. Okay, so without further ado, we're going to go dive straight into electricity questions. Okay, so let's take a look at the first one. Now, before we do any electricity questions, the first thing you need to do is to be able to remember the formula. So what are some of the formulas that you need to remember? So I have this very simple way for you to remember that. In fact, there are a total of 10 formulas that you need to memorize. That is the reason, that is the number one reason why physics, electricity is always so difficult to master. Okay, so in this video, what I'm going to do is I teach you how to remember the formulas, and then after that we will try some questions from the O levels physics and see how they are applicable. Okay, let's go. So first we need to memorize the formula. Okay, so there are several formulas for electricity that you need to memorize. So the easiest and the fastest way that I have discovered is to use this triple triangle. Now, what do I mean by triple triangle? I call this the EPT-IVIR triangle. I know, sounds a bit weird. Okay, so let me write it out to show you what it looks like. Okay, so the EPT-IVIR. Okay, this is called the triple triangle. Okay, EPT-IVIR triangle. So what are all the alphabets and what do they represent? Let me explain every single one of them. Okay, so E here stands for energy. So energy is in terms of joules. That's the SI unit, okay? So T is time. So time SI unit is seconds. So P here is power. Power is in terms of watts, SI unit. Next is voltage, is volts, or voltage. So SI unit is volts. These two I, they represent current. So current is ampere, which is just the letter A, and then R is the resistance. So the SI unit for resistance is ohm. Okay, so this is a very convenient way of remembering three sets of formulas just in one triple triangle. And all you have to do is to keep repeating this EPT-IVIR. You know, you can do it right now, you know, don't be shy, just say EPT-IVIR. All you have to do is to say it like 10-20 times. It will get stuck in the head and you'll remember three formulas. So most students have problem with electricity questions because they do not know. Like for example, sometimes they give you R and then they give you V, you know, and then you need to find current. Okay, so to find current, all you have to do is to take V divided by R. Okay, it's a bit like the DSC triangle, but then this is like stacked 3 times. Okay, next, let's say for example, they give you time and they give you power. So let's say for example, they give you time and then they give you power. So what can you find? You can find energy, which is you just have to take power times time. Alright, so I think you get the idea. The idea is that sometimes they give you different variables and then you are supposed to find another variable. So the problem comes when first you don't memorize the formulas well, and number 2, you do not know you know, what are the SI units and what do they represent. Okay, so this is 3. Remember I said there are 10. This is just 3. Okay, next. Now there's another formula that you need to remember. It's called the I equal Q over T. I equals to Q over T. So I represents the current, Q is charge, which is SI unit is coulomb, which is the capital letter C, and T is time again. Okay, so time SI units in terms of second. So as you go along, you realize that a lot of the SI units as well as the terminology are the same everywhere we use, because SI unit, they have to adhere to the SI unit. They cannot anyhow come up with their own SI units. Okay, so here we have 4. Now how about the other 6 formulas for electricity? So the other 6 formulas for electricity has got to do with parallel and series. So what do we mean by parallel and series? Okay, so I know 6 formulas sounds a bit scary, daunting. You'll be like, oh my god, I need to memorize 6. You know, it's very difficult. Okay, so I will teach you how to memorize it. It's actually pretty simple. So parallel. Okay, let's do parallel on the other side. Let's put series here and parallel. Okay, so how do I remember the formulas? So for each side, there are actually 2 things you need to remember. You need to remember the formula for current, voltage, and resistance. Okay, so what do we have for series? So I equals to what I need to remember, what I need you to remember. I equals to I1 equals to I2 equals to I3. Okay, so you need to remember this one. For series, I equal to I1 equal to I2 equals to I3. Now let me explain how you can remember parallel. Because for parallel, for current, I equals to I1 plus I2 plus I3. Now I'm going to use another color to show you what I mean. So take note of this. If this is equal, you see on this side is equal, this side will be plus. Okay, one side equal, one side plus. Now how about for voltage? For voltage, V equals to V1 plus V2 plus V3. Okay, I know I'm not explaining the theory and the practical part how it works. I just want to remember first. Okay, so if this side is plus, this side they're all plus, the other side will be equal. So V equals to V1 equals to V2 equals to V3. So far is it okay? And then for resistance, for parallel, 1 over RT equals to 1 over R1 plus 1 over R2 plus 1 over R3. And for the other side, the series is RT equals to R1 plus R2 plus R3. Okay, so there you go. You got 10 formulas. Now, first of all, before you can do any electricity questions, all these 10 formulas you have to know. You have to so-called download into the brain before you can apply. If you didn't download this information into your brain, there's no way you can execute the questions. Okay, now let's just go through them one more time. So on the left we have series, and then on the right is parallel. So in case you're wondering what this is all about, let me just draw a circuit to show you. Okay, so series circuit is going to look something like this. So imagine there is like a bulb here, 1, 2, 3. Okay, so this is series, and then parallel like this. So 1, 2, 3. So parallel looks like that. Okay, just a sketch. Okay, just a quick sketch. So what the formula tells me, this I1 equal I2 equal I3, right, is that the current is the same throughout the whole thing. Okay, so current, because this is series, so the current around is the same. Now where is I1, I2, I3? So let's say for example I put an ammeter here, so over here, okay, let's just call this I. And let's say I put an ammeter here, I1, I2, I3. Okay, the currents are all the same because it's a series, it's a loop, so the flow is the same. So however, for the parallel, okay, for current is different. So let's say I is here is I1, I2, I3. Okay, the total current over here is the summation of your I1, I2, and I3. Okay, that's what it means. Next, How about voltage? So let's say I want to find the for series. So V equal to V1 plus V2 plus V3. What does it mean? This is the V, the battery, the voltage. Let's say I set up a voltmeter here, V1, oops, V2, V3. Okay, so let's say for example V1 is 2, this one is 3, this one is 4. What's the total voltage at the battery? You take 2 plus 3 plus 4, so that's 9 volts. Okay, that's what it means. Whereas for parallel, see the parallel formula says that V equal to V1 equal to V3. Okay, it just means that if this is a 9 volt battery, if I put a voltmeter, okay, I don't have enough space to draw, but you can imagine. So here it will be 9 volt, below is 9 volt, and then below here is also 9 volt because V equal to V1 equal to V3. Simple. Okay, so the first thing before you can do any electricity question is you got to be able to put all this stuff into your head. Now for Sec 2, most of you will be tested just on based on these two. Okay, these two formulas that you see over there. Okay, these two formulas, usually they like to test these two formulas, but as you progress, you go to Sec 3, there's like be it you take combined physics or pure physics, you will be exposed to this. Yep, okay, and then for some Sec 2 students, especially those in IP, so I have students from Catholic High, students from other secondary schools, Cedar girls that's doing like IP, level kind of physics. They give you the whole set of stuff, okay? So you gotta learn all 10. Now, these are not all the formulas. There's actually some more, okay? There's if I'm not wrong, there's like one more. But I'm not going to go that one. Let's just solve this first. Okay, so knowing this will be enough for you to clear, I would say about 90% of the questions that you have in your mind. Okay, for electricity. So let me just summarize again what you need to know. First, triple triangle, EPT, IBIR. Next, I equal Q over T. And last but not least, series and parallel. For series, you just need to remember, the strategy here is you just need to remember one, okay, which is the, let me just highlight in green, this one, which makes a lot of sense because it's series, right? So it's the flow is the same. So I equal to I1 equal to I2 equal to I3. You just remember series I equal to I1 equal to I2 equal to I3, and then everything else is opposite, meaning if this is equal, this will be plus, then here is plus, and this is plus, okay? And then you can deduce 4. There's 1, 2, 3, 4. You can deduce 4 formulas already, okay? And then last but not least, the resistance. Now resistance is slightly easier to remember. It is R1 plus R2 plus R3, and because this one is so special for parallel, 1 over RT equal to 1 over R1 plus 1 over R2 plus 1 over R3. 10 formulas, okay? You need to remember that. So cooker has a power of 200, so P, this is 200. Connected to 240, so voltage 240 volts. The current, so can you see that? To find current, what do I need to do? I equals to divide 200 over 240. Use calculator here. Yeah, you gotta use calculator because you are O-level student. Divided by 240, 5 over 6. Yeah, okay, so it's 5 over 6 ampere. So answer is 5 over 6. Okay, next, the cost of using the cooker for 16 hours. The cost for 1 kWh is 25 cents. So we want to use the cooker for 16 hours, and 1 kWh is 25 cents. So, and then we look at our EPT IBIR formula. There isn't a kWh, okay? But the idea is this: 1 kWh of energy. So where is the energy here? It is the E at the top, okay? So to find energy, what do you need to do? You need to take power times time. So the power here is 200. Let me use blue. Now 200 is watts. So it's 200 watts. Now 200 watts, I must convert to kilowatt. Why? Because the SI unit here is kW. so it's actually 0.2 kW. Okay, next I have hour. Because the time is not second anymore, they need hour. So 16 hours. So in terms of the energy used, is 0.2 times 16. That will give me 3.2 kWh. Okay, it's 3.2 kWh. That is the amount of energy used in terms of kilowatt hour. But they say that it's 25 cents per kWh. So yes, it's in terms of cents. So we take 3.2 times 25, 80 cents. Okay, answer 80 cents. Next. Okay, so this is another question. To fully charge a battery for a portable, a current of 3 amperes is used for 5 hours. So how much charge does the battery store? So I mean, we go back to our database. EPTIVRR, does it have charge? No. So what's the formula that we know that has charge? It's I equals to Q over T. Okay, so current equals to charge over time. So now we need to find charge. This is charge. So to find Q equals to IT. Okay, so I have a current of 3 and the time is 5 hours. 5 hours, you know. So clearly I is 3. Now 5 hours I need to convert to second. Okay, so I take 5 times 60 times 60. That is second, because the SI unit for time is second. So 3 times 5 times 60 times 60. 54,000 coulomb. Answer is C. Okay, let's continue. Okay, what are the values of V and IT? Okay, so this particular question has got parallel. Okay, so what does this mean? This means you will need to use the 6 formulas. Alright, so the circuit contains a battery of EMF V connected with arrangement of 2, 3, 4 resistor. Whoa, looks nasty. Okay, so the current is 3 and the current in the wire is IT. What are the values of V and IT? Let's calculate. Okay, so first of all, now these two are connected in series. So what's the total resistance? So RT, according to the formula, RT is equals to, you gotta add the 2. So total resistance is 2 plus 4 equals to 6 ohm. Okay, so here is 6 ohm. Now, what other information did they give us? 2, 3, 4. The 3 is 3 ampere. Okay, so I can calculate the voltage. Okay, why? E, P, T, I, V, I, R. This triangle. Okay, what does it say? Voltage equals to current times resistance. So I have current, I have resistance. So can I find voltage? Yes, so I just multiply. So 3 times 3 is equals to 9 volt. So here also 9 volts. And this is also 9 volt. Okay, what does this mean? This means V must be 9. So it's either A or B. Okay? Very simple. So why? Because it's parallel. So parallel, according to what we memorize, V equal to V1 equal to V2 equal to V3. So 9 volt, 9 volt, 9 volt. Next, I need to find IT. So finding IT is a bit more troublesome because I need to find the total resistance. So how to find total resistance? Using the 6 formula, 1 over RT equals to 1 over R1 plus 1 over R2. So 1 over R1 is, this is 3 here. So 1 over 3 plus this 1 over RT. Then 1 over R2, 6. Okay, use calculator and then together. Oops. Plus 1 over 6 half. So 1 over RT equals to half ohm. So since 1 over RT is half ohm, RT equals to 2 ohms. Okay, so RT equals to 2 ohms here, total resistance. So now I have RT equals to 2, I have the voltage equals to 9. What can I find? I mean, let me just highlight what I have. So voltage is 9, R is 2, I can find I. So how to find I? 9 volt divided by 2 ohm equals to 4.5 ampere. So answer is B.